All right, so our objective today, oh, there I go, leaving other colors there. Our objective today is to learn how to apply techniques for solving systems to word problems with two unknowns. Now, the word problems you're going to work on for homework come from the same page you did homework on for the last couple nights, and then also the page that you did on Tuesday night that dealt with substitution, okay? So all those techniques, substitution, elimination with multiplication, the only one we probably won't practice would be graphing on these, are going to come into play. And which one we use is pretty much dictated by what our equations end up looking like that we translate in our problems. So what I want to do is just kind of remind you the process. BB, that makes me give chills, please. Thank you. Denise is like, what was he doing? Oh my gosh. Sucking on the things for his hoodie. Too bad they can't see me shiver as I write this. Anyway, let's talk about going through the process of solving word problems. So I know this is going to sound goofy. I write it every time, but it's so vitally important. And perhaps after reading a couple of the questions from the test that you may not have done so well on, you got to read. So you need to read the problem thoroughly. And thoroughly also encapsulates repeatedly. You can't just get through reading once and then bam, you got it all down, okay? That takes a lot of years of practice before you pick up on stuff, but you're always going to hit some questions where you have to stop and go, wait a second, let me read that again. So I generally minimally read a question twice. The first time I'm just trying to get an idea of what the question is about. I'm not looking mathematically, what are they asking me to solve for? It's like, oh, it's about these two people and we're trying to figure out what their ages are. Okay, I got it. And then you go the second time and you start trying to find information that talks about when do I add, when do I subtract, if I multiply, if I divide. So then I'm starting to look for the math pieces so I can write out my equations. So that's incredibly important that you read the problem thoroughly. Now, in the problems that we're going to deal with, there's going to be more than one unknown. So we're going to define the unknowns. So remember how you define, you pick a variable, and then in words you tell me what it represents. So it could be as simple as a number, or it could be as complicated as Martha's age now, okay? Or even more than that, number of hours Tricia worked last week, okay? Once we do that, we're ready to read and create math sentences out of English. So that's called translating. So we're going to translate not one, but two equations. The number of unknowns dictates the number of equations we need in order to solve. Okay, so that's generally how it works. Two unknowns, I need two equations. I need that system to help solve for the two unknowns. So to translate two equations. And then you're going to, solve using one of the techniques on solving systems. So we have two major and one related strategies. Major substitution, major elimination. Related to elimination was you had to multiply one or both equations in order to eliminate. So solve using one of the techniques on solving systems. And here comes the key one. And I'm going to yell at you. The answer, maybe if I spell it correctly, that would be more helpful. Answer is not an ordered pair. That's the hard part. We're so used to solving a system and getting an ordered pair that we think that's how we're supposed to write it. But that's not what we get in a word problem. Okay? Ding.
I'm kind of confused on what number 3 is.
Translate two equations. Translate means take the English and write a math sentence out of it.
Oh.
But we don't have one. We're going to get two of them because that's how we solve when we have two unknowns. Okay?
Like take it from like a word problem.
You're going to get a word problem, and instead of there being one equation that you get to translate from all the words there, you're going to end up coming up with two different ones. Okay? So you'll see. I'll give you an example. All right, and then the last thing is to write the answer in sentence form. Okay, so you've got to make sense of your answer. And you should, if you're writing down and say, Johnny is 5 years old and his dad is 7 years old, that you're going to go, whoop, wait a second, dad was 2 when he had him? No, that's not right. So we got to put on that cap of, is this reasonable? Because you guys have given me some really unreasonable answers in the past, and I really don't want to see a bunch of unreasonable answers now. Remember having negative soccer teams? Yeah, that was an interesting answer. Okay, so let's do a word problem. So, you got to write this down. The sum of two numbers is 5. The larger number exceeds twice the smaller number by 14. Find the numbers. So the sum of two numbers is 5. The larger number exceeds twice the smaller number by 14. Find the numbers. Now, this is not Common Core-esque. Common Core tends to put a lot more words in there and gives you background information. These numbers are coming from a situation, whether it was from sales or from whatever. So that's going to be the big difference when you see word problems, especially on the SBAC, is they're going to have more of a story behind where those numbers came from. Okay? They want you to relate it to the real world. That is not some arbitrary math problem I'm doing. Okay, so what am I solving for in this problem? What are they asking me to find? Carly. So they asked me to find two numbers, and I like that Carly picked up on the language that they used. They just didn't call them numbers. They gave them specific names. They called them the larger number, and they called them the smaller number. So when I define my two variables, I'm going to define them exactly the same way. So I'm going to say x, just by default, is the larger number because I picked blue. This problem would get solved exactly the same way if I picked x to be the smaller number. It really doesn't matter. And y equals the smaller number. The reason why I want to describe them as specifically as possible so that when I'm translating, I know which number goes where. Okay? All right. Now I'm supposed to translate two equations. So I go to the first equation, or first sentence. The sum of two numbers is 5. How could I translate that into an equation? Sierra. Yeah, the sum of two numbers means to add them. Is means equals, and then I get 5. That was an easy one. Now the second one, maybe not be so easy. It says the larger number exceeds twice the smaller number by 14. Stereotypically, we hear a word that tells us equals, and generally speaking, that word is the to be verb. But there is no to be verb in this entire sentence. So we actually have one word that plays double duty. He plays the equal sign, And he also explains what math is to be done in the problem. What word plays that dual role in that second sentence? Veronica. Not twice. Carly? Not by. Alex, I'm hearing you say it. Exceeds. The action word is your equal sign. Exceeds is the only verb in that sentence, and that's what an action word is. So that is going to be your equals right here. It also indicates math that's going to go on. What math does exceed, and it kind of goes exceed by, goes together. What math is that? Add, subtract, multiply, divide. Ben. Yeah, we're going larger. We're greater than. That's what exceed means. So let's translate it. It says the larger number, according to our definition, oops, that's x. Exceeds, that means equals. Twice the smaller number by 14. How do we write twice the smaller number? Isaiah?
2y plus 14.
2y. And then the exceeds by means we have to add on that 14. All right, look at the system that we've created. Of the techniques that we've studied, which technique is begging to be used on this problem? Look at what you got. Look at what you got. Sarah, don't whisper it to her. Raise your hand. What do you think it is?
Substitution.
This is perfect for substitution, right? And the reason why it's perfect for substitution, they've already have one equation solved for one variable. So great. So that's what I'm going to do. I'm going to substitute. So I'm going to substitute for x 2y plus 14. And then I write out the rest of the equation. And then I notice I have like terms, so I combine them up, and I get 3y plus 14 equals 5. Subtract 14 from both sides, and I get 3y is equal to negative 9. Divide both sides by 3, and I get y equals negative 3. Now, is there anything in the problem that says the answer has to be positive and it can't be negative? All it talks about is numbers. So this is the first time when kids freak out and they're like, oh, it can't be negative. There's nothing in the problem that says it can't be negative. So that works for me. Let's go ahead and figure out what the other answer would be. Now I have two places to substitute it in. I'm just going to substitute it in here. And I get x plus negative 3. And I know that's not how we would normally write it, but I'm just trying to drive home a point. And I want to get x alone. So what I need to get rid of is the negative 3, and to do that I'm going to add 3 to both sides. So what I get is x equals 8. So we can test it. Is 8 plus negative 3 equal to 5? Yeah. Is 8 equal to 2 times negative 3? Okay, yeah. So it works. So here's how I write my answer. The numbers are 8 and negative 3. Okay, and that's what you're going to be doing on your homework tonight.